Welcome to this episode of Mentors at Your Benchside, the podcast giving you advice, tips, and tools for getting the most out of your research. I'm Eva Amson, and today I'll be talking to you about cleaning and calibrating your lab balance. Your lab weighing scales are one of your most commonly used bits of equipment in the lab, so we've put together an easy guide on how best to clean and calibrate your lab balance. Following this simple guide will ensure that your balance remains clean and, perhaps most importantly, will provide you with accurate readings. Throughout this episode, I'll be using the term weight, even though mass is technically the correct term. So let's start with everyday cleaning for your scales. We understand things can get a little messy during the weighing process, but be sure to use a small balance brush to gently sweep any residue from the balance, and do this every time you use them. This ensures that the risk of cross-contamination stays low. Now, sometimes you need to deep clean your lab balance, and how often deeper cleaning of your scales is required will depend on a couple of factors. How often they're used and how good you and other members of the lab are at keeping up daily maintenance are key. Even if they look okay, be sure to give them a more thorough clean every couple of months or so. And we've got a list of do's and don'ts for cleaning your lab balance. First, the do's. Moisten a thin wipe like a Kim wipe with purified water and carefully clean the pan and around the scales, and then wipe it dry. Do remove the pan to facilitate a more thorough cleaning to maintain your lab balance. And if you've moved your scales and it has a leveling bubble, check that it's centered. But there are also some things you shouldn't do. Don't press down on the balance pan, as this can damage the internal mechanism, particularly for scales that can measure very small weights, so be gentle. Don't turn the scales upside down and shake them to help remove residue. Don't be abusive. And of course, don't drop the scales or put them down on the surface roughly. Imagine the scale is a sleeping baby. Only move it if you have to, and do it with all the tender care with which you're capable. Don't use cleaning fluids that are harsh, as they can react with agar, salts, and other common ingredients. Check the user manual of your scales for recommended cleaning products if you need to. Don't leave salts on the scales. This can corrode the scales, resulting in poorer performance. So after that, after you've cleaned everything, you might need to check the accuracy of your scale as well. So why is it important to do this, and how do you check accuracy? First, you want to ensure that your scales are completely free of residue before you check the accuracy. Now, accuracy is how reliably the scales are at measuring the weight of a sample, and this can be deduced by several tests that are designed to help you ensure that your scales are functioning at peak efficiency. And the first is the repeatability test. If the minimum weight capacity of your scale is 1 gram and the max is 100 grams, measure out a weight somewhere on the upper end of this, say 75 grams. You're looking for a weight value of about 50 to 100% of the weighing capacity of the instrument, so kind of in that top half. Ideally, you should use standard weights to do this, but if you're stuck, you can improvise, so you can measure out 75 milliliter of water, for example. But be aware that not having a sample of known weight means that you'll be able to spot random error, but not systematic error. Please note that your sample must have reached thermal equilibrium before it is used. And whatever you're using will be referred to as the sample here. So each time you weigh a sample, your scale should give you the same weight within a certain margin of error. And this accuracy is stated in your scales manual, or it can be found on the manufacturer's website. Now you place and remove the sample 10 times and record each reading as soon as the balance indicates that the reading is stable. And then work out the range of values and see if it is within the acceptable margin of error. If it is, great. If not, it might be time to calibrate your scales. The other test you can do is the pan position error test. Now your scales should be able to weigh your sample accurately, even if you've placed the sample off-center. To test this, note the weight value given when your sample is placed in different positions on the scale's pan. Now, if you go to the original article, which you can find in the episode description, there will be an image that shows the pan of a scale with the samples placed in 9 different locations, 1 exactly in the middle, and then 8 in a circle around it. So these are the different locations on the pan where you should be able to get the same value when you put your sample there. And again, look at the range to tell you how consistently your scales are weighing your samples across these different pan positions. And the third test you can do is the linearity test. Here you take 2 samples, each with a weight of half the weighing capacity of the scales. Add sample 1 to the scales and note the value, then 0 the scales, and add sample 2, note the value, and add sample 1 alongside sample 2. If the value changes outside of the acceptable range, again, it is time to calibrate. So, calibrating a lab balance. When do you need to do that? There are a couple of times, we've already mentioned a few, when you should recalibrate your scales. The first is when you first buy it. The second, when you move it somewhere new. The third is when there is a significant change in ambient temperature. The fourth, when the scales have been unplugged for a while. And the fifth is if you notice that the accuracy is off. So how do you calibrate? There are 2 forms of calibration, external and internal. There are 2 main options to calibrate your lab balance depending on your individual balance. Nearly all balances can be externally calibrated, but some also have the option for internal calibration. Internal calibration is performed with little to no input from the user and can be triggered manually or set automatically at predetermined times, for example overnight or during lunchtime. Check with your lab manager or lab head to find out if your scales automatically perform internal calibration, and refer to your user manual for how to manually trigger internal calibration if needed. External calibration is necessary for scales that do not have an internal calibration mechanism. It involves using calibrated weights of set amounts, and these will differ depending on your specific balance. Check with your lab manager to see if your lab has a process and a dedicated person for externally calibrating scales. Because of the need for calibrated weights and training, many labs outsource external calibration of scales to an outside company. Inform your lab manager or lab head if this is the case and if you feel calibration is necessary. Now note that calibration does not necessarily mean that any adjustments will be made to the balance. Calibration is a specific way to check the accuracy of your scales. If the accuracy is outside the tolerated limits, then adjustments may be necessary. In this case, you will need to get your balance adjusted and serviced by a qualified supplier or company. So to summarize all this, you should now have a good grounding on how to clean and calibrate your lab balance. And the main points we discussed today is that you should lightly clean your balance before each use and clean up any spills. Deep clean balances regularly, but be careful to ensure that you use appropriate cleaning solutions as harsh chemicals can damage the scales. Regularly check the accuracy of your balance using the repeatability test, the pan position error test, and the linearity test. And calibrate your lab balance where possible, either using the internal calibration function or via external calibration. So that's it for tips for cleaning and calibrating your lab balance. And check out the episode description for links to related articles and resources. And don't forget to subscribe to the podcast to get more help and advice from mentors at your bench side.